My name is Ana Paula Pagnoncelli. I'm a PhD student at Politecnico di Torino. And the work I'll be presenting is called Evaluation of Mechanical Strength on Graphite R4550 using ultrasound tensile testing. So in this presentation, I'll go through the method used to evaluate the graphite's mechanical strength. In the existing methods for tensile testing of brittle materials have some limitations, such as the gripping interface, the alignment of the testing machine, and also the testing machine strength that limits the maximum cross-section that of material that can be used. So in the ultrasound tensile testing method, the same machine used in the very high cycle fatigue tests is adopted. And but in this case, we aim to rupture to cause the failure of the specimen in as few cycles as possible, so to avoid the fatigue fracture. In this machine, there is a range of amplitude between 2.5 to 25 micrometers that can be applied at the amplitude of vibration that can be applied at the horn's base, which is then amplified by the machine by 4.8 times. The interface between the horn and the specimen has a normal strain that's equal to 0, which allows the specimen to be fixed at the horn by a simple adhesive. And only one of the specimen's extremities is fixed, so there is no alignment. There are no alignment problems. And finally, the resonance phenomenon is what causes the normal strain that will bring the specimen to rupture, which limits less the maximum section of material that can be used. So the first step to this procedure is a numerical analysis, so that the specimen can be designed to guarantee that the frequency of the system is around 20 kilohertz, and that the machine's amplitude range will be able to cause the failure. Also, the numerical analysis helps optimize the positioning of the strain gauge and the camera recording zone, so that it will be guaranteed to acquire the failure zone. Also, there is a laser pointed at the bottom of the specimen, which measures the vertical displacement. Finally, the numerical analysis will serve to verify the experimental results. The first step to the experimental procedure is a microcomputed tomography scan of the specimen, which in the micro-CT, the machine takes projection of the specimen in various rotating positions, and then those projections are used for a 3D reconstruction of the specimen, so that the internal defects can be detected. The source object distance divided by the source detector distance is what gives the final resolution in the projections. Each sample, each specimen will be scanned before the ultrasound tensile testing for defect analysis purposes, and then the pieces after the ultrasound tensile testing will also be scanned, so they can be overlapped with the original scan to identify which defects were present in the failure zone. So here there is a pre-test scan of a sample showing the defects identified inside the sample. These are the slices, the frontal slice and the cross-section slice, showing the biggest defect that was identified in the failure zone, which is this one here. And here at the bottom, it's the slices in the same positions of the overlapped pieces after the ultrasound test, showing that the fracture thus passes over the identified defects. Incidentally, this one was next to another big defect, so it makes sense that the fracture passes through both of them. And then in the tensile, the ultrasound tensile testing, the machine was set up to get to a maximum of 10 micrometers of amplitude of vibration at the horn's base, and it should take 10 milliseconds to reach that amplitude of vibration. The camera had a recording speed of 420,000 frames per second, and a resolution of 24 per 512 pixels, which allowed the camera to capture a zone of 13 millimeters at the center of the specimen. In the recording, it's shown that the fracture in this specimen occurred a little below its center, which is also confirmed by measuring the scanned pieces after the second CT scan, showing that the top piece is indeed larger than the bottom one. This specimen in particular withstood 101 cycles until failure, and the time to failure was 5 milliseconds, which was not enough time to the machine to get to its final amplitude. So to analyze the results, the specimen's defects on the fracture zone will be taken into account, as well as the characteristics that could define their criticality.
Stop the microscope.
And
please stop.
And their stress intensity factor, while the ultrasound test will provide the strain amplitude in the moment of failure at the failure position with the number of cycles until failure, and this data will contribute to evaluate the graphite R4550's mechanical strength. And thank you for your attention. If you have any questions, I will be happy to answer.